कैसे हो भाई? आज एनर्जी थोड़ी डाउन लग सकती है मेरी, या तो ज़्यादा भी लग सकती है, मेरे को नहीं पता कैसे जाएगा। अरे यार लिटल जीरो छोड़ो, ये सब मैं क्यों देख रहा हूँ पता है, लेकिन क्यों देख रहा हूँ मैं ये सब? तो मैं कुछ अच्छी चीज़ दिखाता हूँ। एक व्यू जो मेरा ही होगा खुद का, 7 व्यू। चलो तुम्हें कुछ दिखाता हूँ। आ गया। हम्म, ये देखो, आज मेरे को पहला कमेंट मिला भाई जीवन का 3 घंटे पहले। प्रवीण भाई, याद रखेंगे चलो। तो देखेंगे बाद में। तब तक चलो, कहाँ थे हम? फिनिश कर लेते हैं थोड़ा, उसके बाद बुराई करना चालू करेंगे लोगों की। यूर ऑन अ रोल। अच्छा, अरे कुछ तो दिया है, रो हट मेरे मुंह के सामने से। 15 पर हट का चोर का बच्चा।
Alright, so now let's tackle a really big topic, functions. So far in the course, all the programs that we've been writing have been written inside of main. They're pretty simple programs. We don't need to have all these branches and things going on. We can just fit it all inside of main and it doesn't get terribly overwhelming. But as the course goes on and as you begin to develop programs independently, they're probably going to start to get a lot more than 10 or 15 lines. You might get to hundreds or thousands or tens of thousands of lines of code, and it's really not that crazy a thought. As such, it's probably not a good idea to keep everything inside of main. It can get a little difficult to find what you're looking for if you do that. Fortunately, though, C and pretty much every other programming language that you might work with allows us to write functions. And I'm just going to take a quick aside here to mention that functions is one area of computer science, and you'll see many more of them at various points throughout the course and if you continue on, where there's a lot of synonyms for the same word. So we call them functions, but you might also hear them referred to as procedures or methods, particularly if you've ever done any object-oriented programming before, and don't worry if you haven't, not a big deal, but in object-oriented languages they're frequently called methods. Sometimes they're called subroutines, but they really all refer to the same basic idea. Let's see what that idea is. What is a function? Well, a function is really nothing more than a black box that has a set of 0 or more inputs and a single output. So for example, this might be a function. This is a function called func, and it takes 3 inputs, A, B, and C, and inside that black box, we don't know exactly what it does, but it processes the inputs in some way, and it gives us a single output, in this case, Z. Now, to make it a little less abstract, we could say that maybe we have a function called add that takes 3 inputs, A, B, and C, and processes the output in some way inside the black box to produce a single output. So in this case, if add takes 3, 6, and 7, somewhere inside the add function we would expect them to be added together to produce the output, which is 3 plus 6 plus 7, or 16. Similarly, you have a function called mult that takes 2 inputs, A and B, processes them in some way such that the output of the function is the product of the 2 inputs multiplied together. 4 and 5 being passed into mult, something happens, the output we expect is 20. Why do we call it a black box? Well, if we aren't writing the functions ourselves, which we've done quite a bit so far in CS50, we've seen printf, for example, which is a function that we didn't write ourselves, but we do use all the time. If we aren't writing the functions ourselves, we don't really need to know how it's actually implemented under the hood. So for example, the black box I just showed you for multiplication. Mult AB could be defined, and this is just some pseudocode, could be defined as output A times B. That makes sense, right? If we have a function called mult that takes 2 inputs, we would expect that the output would be the 2 inputs multiplied together, A times B. But mult could also be implemented like this. We could have a counter variable that gets set inside of mult to 0, and then we repeat this process B times. Add A to counter. So for example, if we multiply 3A by 5B, we could say set counter to 0, repeat 5 times, add 3 to counter. So we start at 0, and then we do this 5 times. 3, 6, 9, 12, 15. It's the same result. We still get 3 times 5, just the implementation is different. That's what we mean when we say a black box. It just means we don't really care how it's implemented under the hood as long as the output is what we expect. And in fact, that's part of the contract of using functions, particularly functions that others write. The behavior is always going to be typical and predictable based on the name of the function. And that's why it's really important when you write functions, or when other people write functions that you might use, that those functions have clear, relatively obvious names and are well documented, which is certainly the case for a function like printf. So why do we use functions? Well, as I said earlier, if we write all of our code inside of main, things can get really cumbersome and really complicated. Functions allow us the ability to organize things and break up a very complicated problem into a lot more manageable subparts. Functions also allow us to simplify the coding process. It's a lot easier to debug a 10-line function versus a 100-line function or a 1,000-line function. If we only have to debug small pieces at a time or write small pieces at a time, it makes that programming experience a lot better. Trust me on that one. Lastly, if we write functions, we can reuse those various parts. Functions can be recycled, and they can be used in one program or another. You've already written the function. All you need to do is tell that program where to find that function. We've been recycling and using printf for over 40 years, but it was only written one time. It's pretty useful, right? All right, so functions are great. We know that. Now let's start writing them. Let's start getting them into our programs. In order to do that, the first thing we need to do is declare the function. When you declare a function, what you're basically doing is telling the compiler, hey, just so you know, I am going to be writing a function later on, and here's what it's going to look like. The reason for this is because compilers can do some weird things if they see a set of symbols that they're not familiar with. So we just give the compiler a heads up. I'm creating a function, and it's going to do this. Function declarations generally, if you're organizing your code in a way that others will be able to understand and make use of, you generally want to put all of your function declarations at the very top of your code, right before you start writing main even. And conveniently, there's a very standard form that every function declaration follows. They all pretty much look like this. There are 3 parts to a function declaration: return type, name, and argument list. Now, the return type is what kind of variable the function will output. So, for example, if we think back a minute ago to the multiplying 2 numbers function, what do we expect if we multiply an integer by an integer, the output will be?
Integer.
Probably an integer, right? Multiplying 2 integers together, you get an integer. So the return type of that function would be int. Name is what you want to call your function. This is probably the least important part of the function declaration in terms of functionality, but it's actually probably one of the most important parts of the function declaration in terms of knowing what the function actually does. If you name your function f or g or h or mystery or something like that, you're probably going to get a little tripped up trying to remember what those functions do. So it's important to give your functions meaningful names. Lastly, argument list is the comma-separated list of all the inputs to your function, each of which has a type and a name. So not only do you have to specify what type of variable the function will output, you also want to specify what type and types of variables the function will be accepting as inputs. So let's do an example here. Let's just take a look at a more concrete one. So here's an example of a function declaration for a function that would add 2 integers together. The sum of 2 integers is going to be an integer as well, as we just discussed, and so the return type here in green would be int. That just tells us that add 2 ints is going to, at the end of the day, output or spit back out to us an integer. Given what this function does, we want to give it a meaningful name. Add 2 ints seems appropriate, considering we're taking 2 integers as inputs and hopefully adding them together. It might be a bit of a cumbersome name, and frankly, this function is probably not necessary since we have the addition operator, if you recall from our discussion of operators previously. But let's just say, for the sake of argument, that this function is useful, and so we'll call it add 2 ints. Lastly, this function takes 2 inputs, each of which is an integer. So we have this comma-separated list of inputs. Now, we generally want to give a name to each of them so that they can be used within the function. The names aren't terribly important in this case. We don't necessarily, have any meaning attached to them, so we can just call them A and B. That's totally fine. If, however, you find yourself in a situation where the names of the variables might actually be important, you might want to call them something other than A and B to give them something more symbolically meaningful. But in this case, we don't really know anything else about the function. We just want to add two integers. So we'll just call those integers a and b. All right, so that's one example. Why don't you take a second to think about this one? How would we write a function declaration for a function that multiplies two floating point numbers? Do you remember what a floating point number is? What would this function declaration look like? I'd actually recommend that you pause the video here and take, however much time you need, really. Think about what this function declaration would be. What would the return type be? What would the meaningful name be? What would the inputs be? So why don't you pause the video here and write up a function declaration for a function that would multiply two floating point numbers together. All right, hopefully you paused the video. So let's take a look at an example of one possible declaration. Float mult two reals, float x, float y. The product of two floating point numbers, which recall are how we represent real numbers or numbers with decimal values in C, is going to be a floating point number. When you multiply a decimal by a decimal, you're probably going to get a decimal. You want to give it a relevant name. Multiply two reals seems fine, but you could really call it mult two floats or mult floats, anything like that, as long as it gave some actual meaning to what this black box was going to do. And again, in this case, we don't seem to have any meaning attached to the names of the variables we're passing in, so we can just call them x and y. Now, if you call them something else, that's totally fine. And in fact, if you did this declaration instead, using doubles instead of floats, if you recall that doubles are a different way to more precisely specify real numbers or floating point variables, that's totally fine too. Either one of those would be fine. In fact, there are several different combinations of ways to declare this function, but these are two pretty good ones. All right, so we've declared a function. That's great. We've told the compiler what it is, what we're going to be doing. Now let's actually write that function. Let's give it a definition so that inside the black box, predictable behavior is happening. And in fact, we are multiplying two real numbers together or adding numbers together or doing whatever it is that we asked our function to do. So in fact, let's try and define multiply two reals, which we just talked about a second ago. Now, the beginning of a function definition looks almost exactly the same as a function declaration, and I have both of them here. At the top is the function declaration. Type, name, comma-separated argument list, semicolon. The semicolon indicates that that is a function declaration. The beginning of the function definition looks almost exactly the same. Type, name, comma-separated argument list, no semicolon, open curly brace. The open curly brace, just as we've been doing with main, means that we are now beginning to define what happens inside the black box that we have decided to call mult2 reals. Here's one way to implement it. We could declare a new variable of type float called product and assign that variable to the value x times y and then return product. What does return mean here? Well, return is the way we indicate that's how we're passing the output back out. So return something is the same as this is the output of the black box. So that's how you do it. Here's another way to implement it. We could just return x times y. X is a float, y is a float, so x times obviously. But also want to specify, just give the compiler a heads up to our programs. And lastly, if we write functions, we can reuse those, that those functions have clear, relatively obvious right. The behavior same result, we still have 5 times b times b. Called mult could be the output of the function is the product of the two inputs multiplied together. 4 and 5 being passed into mult, something happens, the output we expect is 20. Why do we call it a black box? Well, if we aren't writing the functions ourselves, which we've done quite a bit so far in CS50, we've seen printf, for example, which is a function. So functions are great, we know that. That's two floats. All right, so colon indicates that that is, and assign that variable to the value x times y, and then return indicate that's how we're passing the output back out. Is the same as this is the output of the. Here's another way to implement it. We could just return x times y. X is a float, y is a float, so x times y is also a float. We don't even need to create another variable. So that's a different way to implement the exact same variable. X is a float, is the same as this is the variable. Now take a moment, pause the video again, and try and define add two ints, which is the other function that we talked about a moment ago. Again, here I've put the function declaration, and with a semicolon, and an open curly brace and a closed curly brace to indicate where we will fill in the contents of add2ints so that we define the predictable behavior inside the black box. So pause the video and take as much time as you need to try and define an implementation of add2ints such that when the function outputs a value, it does in fact return the sum of the two inputs.
Return a plus b.
So just like the previous example, there are several different ways that you could implement add2ints. Here's one, and here in orange I've just had some comments. I've just added some comments to indicate what's happening on each line of code. So I declare a variable called sum of type int. I say sum equals a plus b. That's where I'm actually doing the work of adding a and b together. And I return sum. And that makes sense because sum is a variable of type int, right? And what's the data type that this function tells me it's going to output? Int. So I'm returning sum, which is an integer variable. And that makes sense given what we've declared and defined our function to do. Now you could also have defined the function this way. Int sum equals a plus b. Skip that first step. And then return sum. Now you could also have implemented it this way, which I highly do not recommend. This is bad style for one thing and really bad design, but it does in fact work. If you take this code, which is in badadder.c, and use it, it actually does add two integers together. It's a very poor implementation of this particular behavior, but it does work, and it's here to illustrate the point that we don't really care what happens inside the black box as long as it has the output that we expect. This is a poorly designed black box, but at the end of the day, it does still output the sum of a plus b. All right, so we've declared functions and we've defined functions, so that's really good. Now let's start to use the functions that we've declared and we've defined. To call a function, it's actually pretty easy. All you need to do is pass it appropriate arguments of the data type that it expects, and then assign the return value of that function, assign the return value of that function to something of the correct type. So let's have a look at this in practice in a file called adder1.c, which I have in my CS50 IDE. So here is adder1.c. At the beginning, you see I have my includes, pound include standard.io and CS50.h, and then I have my function declaration. This is where I'm telling the compiler I'm going to be writing a function called add2ints. It's going to output an integer type variable. That's what this part is right here. And then I have two inputs to it, a and b, each of which is an integer. Inside of main, I ask the user for input by saying give me an integer. And they are prompted for getInt, which is a function that is included in the CS50 library. And that gets stored in x, an integer variable. Then we prompt them for another integer. We get another integer and store that in y. And then here on line 28 is where we make our function call. We are saying int z equals add2ints x, comma, y. Do you see why this makes sense? X is an integer type variable and y is an integer type variable. So that's good. That makes sense with what our function declaration on line 17 looks like. The comma separated input list expects two integers, a and b in that case. We can call them whatever we want. It just expects two integers. And x is an integer, and y is an integer. So that works. And we know that that function is going to output an integer as well. And so we are storing the output of the function add2ints in an integer type variable, which we're calling z. And then we can say the sum of %i and %i is %i. X, y, and z, respectively, filling in those %i's. What does the definition of add2ints look like? Well, it's pretty simple. It's one of the ones we just saw a second ago. Int sum equals a plus b, return sum. Does this work? Well, let's save the file. And then down here on my terminal, I'm going to make adder1. I'm going to clear my screen, and I'm going to zoom in because I know it's a little difficult to see. So we compiled this program as adder1, so we can do /adder1. Give me an integer, 10. Give me another integer, 20. The sum of 10 and 20 is 30. So we made a successful function call. We can run the function again. -10, 17. The sum of -10 and 17 is 7. This function works. It has the behavior that we expect it to. And so we've made a successful function definition, declaration, and a successful function call. couple miscellaneous points about functions before we conclude this section. Recall from our discussion of data types previously that functions can sometimes take no inputs. If that's the case, we declare the function as having a void argument list. Do you recall what the most common function we've seen so far that takes a void argument list is?
Domain.
It's main. Recall also that functions sometimes don't actually have an output. In that case, we declare the function as having a void return type. Let's conclude this section by tackling a practice problem. So here's the problem laid out. I want you to write a function called valid triangle. What this function should do is take 3 real numbers that represent the lengths of the 3 sides of a triangle as its parameters, or its arguments, or its inputs, another set of synonyms that you might encounter. This function should either output true or false, depending on whether those 3 lengths are capable of making a triangle. Do you remember the data type that we used to indicate true or false?
Boolean.
Now, how do you implement this? Well, know there are a couple of rules regarding triangles that are actually useful to know. A triangle can only have sides with positive length. That makes sense. You're probably saying, duh. The other thing to note, though, is that the sum of the lengths of any 2 sides of the triangle has to be greater than the length of the third side. That's actually true. You can't have a triangle of sides 1, 2, and 4, for example, because 1 plus 2 is not greater than 4. So those are the rules that determine whether or not the 3 inputs can conceivably form a triangle. So take a couple of minutes and declare and then define this function called valid triangle, such that it actually has the behavior specified here. It will output true if those 3 sides are capable of comprising a triangle, and false otherwise.
रुक जाओ, बना ही लेते हैं। तो ये कौन सी नोटबुक है? K-pop का है। इसमें ही करेंगे। अब पेन कहाँ गया मेरा? नहीं, पेन की इंक खत्म हो रही है। पेन की इंक खत्म है। एक तो मेरे को बनना नहीं है, पता है सीआर में गलती से बन गया ना, पीछा नहीं छूट रहा मेरा सीआर वाले से। और मैंने वो भी खो दिया, उसका बैच। अच्छा ही हुआ वैसे तो, बैच खो गया तो उसका तो गम नहीं है मेरे को बिल्कुल भी। वैल्यू मेरे नज़रों में नहीं थी भयंकर, बाकी भी नहीं करते थे ज़्यादा कुछ खास। बीइंग अ सीआर इज जस्ट, क्या बोलूं, बस स्पेशली अगर आपको गधों को जो है मैनेज करना पड़े। एक अच्छी क्लास को अगर भाई मिल जाता मैनेज करना तो समझ भी आता है, गधों को कहाँ से मैनेज करोगे वो भी सोचो। क्या था क्वेश्चन? डिक्लेयर and shall declare a write a function called valid triangle, ठीक है, that takes 3 real numbers representing the lengths of the 3 sides of a triangle as its arguments and outputs either true or false depending on whether those 3 lengths are capable of making a triangle। ठीक है, हम लोग फ्लोट वैल्यू भी ले सकते हैं ना, ले तो सकते हैं। मैं फ्लोट में लेना चाहूँगा इसको। फ्लोट ट्रायंगल का नाम क्या है? खाली वही लिख रहा हूँ मैं, उतना कुछ वो फंक्शन नहीं कर रहा हूँ, सिर्फ फंक्शन का उतना लिख रहा हूँ, इंड मेन वो सब नहीं लिख रहा मैं। फंक्शन वैलिड ट्रायंगल, ठीक है, फ्लोट वैलिड ट्रायंगल फंक्शन बोल रहा हूँ ट्रायंगल। इसमें 3 साइड रहेगा ऑब्वियसली, फ्लोट ए कॉमा फ्लोट बी कॉमा फ्लोट सी। डिक्लेरेशन डन। एंड मेरे को नहीं पता प्रोटोटाइप में वो डालते हैं क्या, मैं भूल गया हूँ। देख रहा था यहाँ से, देख सकते हैं नहीं, नहीं डालते हैं। चलो अच्छा, तो शायद हाँ डालते हैं रे बाबा। हम डिक्लेयर कर दें ना तो डिक्लेरेशन में नहीं आता है, प्रोटोटाइप के टाइम चाहिए रहता है। राइट, फिर क्या करना है हमें? serial numbers representing the length of three sides. Okay. hmm. if कर लेते हैं। if पहले तो इनपुट भी लेना है ना उससे, यूज़र से, और वो तो यूज़र उसमें ही दे देगा 5 6 7 जो भी है। if a is a plus b is greater than c and b plus c is greater than a and a plus c is greater than b, ठीक है। इसमें हम बस सिंपली रिटर्न कर देंगे ट्रू, else return false। बस अ, 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 मेरे ख्याल से यही होना
Has
चाहिए।
the behavior specified here. It will behavior that we expect. We declare
और यहाँ पे और किया है, चेक फॉर ऑल पॉजिटिव साइड्स। अच्छा हाँ, यहाँ पे पॉजिटिव भी तो होना चाहिए, वो हमने चेक नहीं किया। एनी टू साइड्स। एल्सिफ कर देंगे यहाँ पे। हाँ ठीक है, हम इसको इम्प्रूव करेंगे। यहाँ लिख देते हैं इनकम्प्लीट कोड, तो दोबारा देख के हम लिखेंगे कंप्लीट कोड। फंक्शन ऊपर साइड
our
में
function at the very top, bool, valid triangle, float x, float y, float z.
ओह हाँ भाई, अरे अरे भयंकर, फ्लोट क्यों मैं कर रहा हूँ, भूल, ये भी एक चीज़ था। और हाँ, रिटर्न में फॉल्स क्यों करेगा जब उसका रिटर्न टाइप फ्लोट है? तो दिमाग तो थोड़ा वो बेवकूफ़ का बच्चा, ध्यान नहीं दिया। लेकिन उसने 2 बार क्यों लिया? अच्छा, उसने प्रोटोटाइप भी एक बार ले लिया है। ठीक है भाई, बोल। अब मैं खुद से करूँगा बिना देखे ये वाला पार्ट। यहाँ से उस पर वापस जाओ, पाए क्वेश्चन पे।
Not the only one, yours might vary. Has the behavior specified here. It will out
ऐसे पॉजिटिव लें, बोल वैलिड ट्रायंगल, ठीक है। float A, float B, float C, and boom. एंड देन यहाँ पे हम एक और बार ले लेंगे वैलिड ट्रायंगल, सेम चीज़ लिखना है, फ्लोट ए कामा फ्लोट बी कामा फ्लोट सी। अब इसमें यहाँ पे खोल देते हैं। अब वो चेक करेगा नंबर्स, लेकिन वहाँ पे और क्यों यूज़ किया, मतलब कोई सा भी of any two sides of the triangle must be नहीं, अगर मान के चल ले -7 + 60 है, ठीक है, नहीं -1 तो ले ही नहीं सकता, बात सही है, 60 और 1 है, ठीक है, और तेरा, रुक जाओ पहले ये कर लेता हूँ मैं अपना, उसके बाद वो करेंगे बात। लेस देन इक्वल टू 0, बस इतना ही तो आएगा, और क्यों आएगा बाकी कुछ, उसने बहुत कुछ लिखा था, देखने दो क्या लिखा था उसने। ओह हाँ हाँ हाँ, ठीक है ठीक है ठीक है। if a is less than equal to 0 or b is less than equal to 0 or c is less than equal to 0, return false। मतलब एक लाइन का कोड के लिए मेरे को नहीं पसंद है वो लिखना, डिक्लेयर करना, रिटर्न फॉल्स, ठीक है। देन अब चेक करेगा इफ a प्लस b इज ग्रेटर देन c। अब यहाँ पे एंड क्यों आएगा, और क्यों आएगा वो मेरे को नहीं समझ आया। b प्लस सी इज ग्रेटर देन, मैंने दो बार ग्रेटर क्यों लिखा था, और a प्लस सी इज ग्रेटर देन, ओ, और मेरे को समझ आ गया क्यों दिया था उसने, उसने यहाँ पे साइन ऐसे कर दिया था, अब समझ आया, उल्टा साइन किया था वो, उसने एंड में ट्रू रिटर्न किया है, तो हाँ ठीक है मैं भी यही करूँगा, रिटर्न फॉल्स, ज़्यादा बेटर है, नहीं तो रिटर्न ट्रू कर देंगे यार, क्या हो गया बस।
Of comprising a triangle behavior that we expect. We declare our function at the very top, bool valid triangle, float x, float y, float z. So again, this function takes 3 real numbers as its arguments, floating point value variables, and outputs a true or false value, which is a Boolean, recall. So that's why the return type is bool. Then we define the function. First thing we do is check to make sure that all of the sides are positive. If x is less than or equal to 0, or if y is less than or equal to 0, or if z is less than or equal to 0, that can't possibly be a triangle. They don't have positive sides. And so we can return false in that situation. Next, we check to make sure that every pair of inputs is greater than the third one. So if x plus y is less than or equal to z, or if x plus z is less than or equal to y, or if y plus z is less than or equal to x, that also can't be a valid triangle. So we return false again. Assuming we passed both of the checks, though, then we can return true, because those 3 sides are capable of creating a valid triangle. And that's it. You've now declared and defined and you may be able to now use and call this function. Great job. I'm Doug Lloyd. This is CS50.
थैंक यू। ओए कितने बढ़िया टीचर्स है भाई, चोरों जैसे टीचर्स भरे पड़े मेरे कॉलेज में। मजाक से हट के कह रहा हूँ, पहला सेमेस्टर ठीक था, सेकंड सेमेस्टर आती जो दिमाग खराब हुआ है ना, गंदे से घटिया से पुअरली डिजाइन नोट्स, पढ़ाने का तरीका एकदम ना कुछ वाइब है, गंदा सा बोरिंग वाइब। स्कूल की याद दिला दी भाई, 9th 10th की। 9th 10th बोल रहा हूँ, 11th 12th बहुत बेटर।
As you start working with functions, another thing is going to become really important to understand, which is the concept of variable scope. So scope is a characteristic of a variable that defines from which functions that variable can be accessed. There are two primary scopes in C: local variables and global variables. Now, local variables can only be accessed within the functions in which they're created. They can't be accessed by every other function that exists in your program, only the function in which it was created. Global variables, on the other hand, can be accessed by any function in the program, and the reason for that is because they're not created inside of any particular function. We declare them outside of all of the functions, which means that every function knows where it is and can access and manipulate it. So far in the course, you've pretty much been working exclusively with local variables. Here's an example of a very, very simple main function and a very simple additional function that we've written. In this case, x, which I've colored green just to highlight the locality or the scope of that variable, is local to the function triple. Main cannot refer to x at all. It doesn't know what it is. No other function, in fact, if we had additional functions in here, could refer to x. Similarly, results, which I've colored
सोने के टाइम तो उधर चला जाऊंगा, लेकिन पढ़ने के टाइम तो यहीं रहता हूँ ना, पढ़ने जो भी करता हूँ। मेरा बंद करना पड़ेगा। कब है मेरे को अपना बोतल निकालने दो फ्रिज से, ऐसी होगी पढ़ाई मेरी। ठंडा पानी का बोतल, अरे बर्फ। सुनो सुनो, एक ट्रिक बताता हूँ, सुन तो कोई नहीं रहोगा पर फिर भी एक ट्रिक बताता हूँ। मस्त जो है बोतल रखो फ्रिज में, उसको पूरा जमा दो पानी भर के, ठीक है। जब तुम्हारे घर लाइट कटती है या फिर ऐसा कुछ सीन होता है जैसे मेरे पंखे की वाट लग चुकी है, ठीक है, कुछ नहीं करना, बोतल निकालो वो ठंडा वाला, को अपने पास रगड़ते रहो अपने शरीर में। अब बाद में जब तुम्हारा हो जाए काम, उसको धो अच्छे से और फिर उसके अंदर पानी, नया पानी भर के फिर डाल दो फ्रीजर में। बहुत बेटर है भाई, चारों लेके आता हूँ, रुको। और एक और ट्रिक ये है कि तुम पानी पीते रहो।
colored blue is local only to main. Only main knows what the variable result is. Triple cannot use it. Now, as I mentioned, global variables do exist. If you declare that variable out, not refer to x, example of a very, very simple main function and a very simple additional function that we've written. In this case, x, which I've colored green just to highlight the locality or the scope of that variable, is local to the function triple. Main cannot refer to x at all. It doesn't know what it is. No other function, in fact, if we had additional functions in here, could refer to x. Similarly, result, which I've colored blue, is local only to main. Only main knows what the variable result is. Triple cannot use it. Now, as I mentioned, global variables do exist. If you declare that variable outside of
कौन फोन कर रहा है चलो भाई आ गया मैं। भाई फोन आया था कुछ तो आंटू इसका
Of
क्या तेरा।
any function, all of the functions in the program can refer to it. So in this case, I've highlighted in green a global variable declaration. In this case, the variable being declared is called global, to be extremely clear about it. It is of type float, and I assign it the value 0.5050. You'll notice that in main and in triple, I am able to refer to global. And in fact, if I go through the program as indicated, main first calls triple, triple multiplies global by 3, which sets its value to 1.5 something, 1.51 or something like that. And then main also prints out the value of global. So main will not print out 0.5050, it will print out global times 3, 1.51. So
हाँ
you got to be careful when you're working with global variables. While they're very
हाँ
flexible in
ट्रिपल
being able
फंक्शन
to
यूज किया
pass
ना इसलिए।
information around so that every function can use it, it also can have some dangerous consequences
ये
if one
कांस्टेंट
function
नहीं है ना।
changes the value of a variable before you expect it to be changed. Why does this distinction matter? Why do we care whether some variables are local and others are global? Well, for the most part, local variables in C are what's called passed by value when we make a function call. What does that mean? Well, when a variable is passed by value, the call E, which is another way of saying the function that is receiving the variable that gets passed in as an input, it actually doesn't receive that variable itself. It receives its own copy of it to work with. This is a really important distinction. We just saw a second ago that with global variables, if we manipulate the global variable in one function, its effect is the effect in that one function carries through to every other function. But with local variables, that's not true. Each function, when it receives variables as input, receive copies of those variables, not the variables themselves. So what is the side effect of that? That means that the variable in the caller, the function that is making the function call, is unchanged unless you overwrite it. For example, in this code, foo is not changed at all. Int foo equals 4, call triple of foo. Inside of triple, we would expect that foo would be multiplied by 3 and returned, but there's actually no effect. Here, though, a very subtle difference, this does have the effect we want. Do you see why? We're overwriting foo
ओह हाँ
in main this time. So int foo equals 4, foo equals triple foo. When we make that call, triple gets its
12
own copy of foo, its own copy of 4.
फू की
It
वजह से
says
12 हो
return
जाएगी।
4 times 3, or whatever variable gets passed in times 3. And then we assign the return value of triple to foo again. So this actually would overwrite foo. This is the only way to do this with local variables. So now, if we added another line of code here at the end of main to print out the value of foo, it would in fact print out 12. Variable scope is generally not too much of a problem if you name all of your variables different things, but it can get kind of nasty if the same variable name appears in multiple functions, which will happen a lot. If you ever do work in the real world, where you are working on collaborative programs and people in different teams are working together to write the same program or the same set of programs, they'll frequently reuse variable names, particularly common ones like X, Y, I, J, and so on. But when variables have the same name, scope issues can get a little trickier to parse. For example, do you know what will be printed out at the end of this particular program?
Let me see
Take a
क्या
minute,
क्या
pause the video.
int int में वर्ड क्या पहले int x में क्या है x प्लस प्लस रिटर्न x प्री इंक्रीमेंट लेकिन रिटर्न x क्या है इसका x इक्वल टू 1 है इंटू y इक्वल इंटू y इक्वल टू इंक्रीमेंट x ठीक है increment 1 printf x is percent I y is percent I slash n tomorrow x is 1 y is ऑल्सो 1 पर 2 भी हो सकता है। 1 मैं इसलिए बोल रहा हूँ क्योंकि ये x प्लस प्लस जो है उसके बाद है, तो शायद वो ऐसा नहीं करेगा।
And
बट
read through
लेट्स
this
से
program. You can see at the top we
x
have a
इज 1
function
y इज 2,
declaration for a function
मैं
called
फाइनली
increment.
कॉल हुआ है।
That function takes a single parameter, an integer, which we call x, and it outputs an integer. That's the return type at the beginning. Then we have main, a couple of lines of code in main, the last of which is a print statement. And remember, that's the question here. What is actually going to be printed at the end of this function? And then we actually have the definition of increment below. So take a minute, step through the code, trace things out. Do you know what will be printed at the end of this particular program? All right, hopefully you've taken a few seconds to try and parse this one out. Let's do it together. So I've crossed out increment declaration at the top there. It was kind of a distraction. It's not its own variable. Doesn't have its own scope. It's just a function declaration. So for purposes of trying to parse out what's happening in this program, we might as well just avoid it. Now, we have, in this case, the reason this problem is tricky is because we have local variables in both main and increment, each of which is called x. And of course, the crux of this issue is trying to suss out which x gets changed and how does it get changed. So I've colored every instance of x that's local to main red, and I've colored every instance of x that's local to increment blue. Notice in that third line of main, y equals increment x, that increment is not being passed main's x or the red x. It's getting passed a copy of it, and it's only going to work with that copy of it, the blue x. If you're mathematically inclined, you might have instead thought of this as x sub m for main and x sub I for increment, but it's the same idea. X sub m, or the red x's in the previous slide, are the variables that are local, is the instance of x rather that is local to main, and x sub I, or the blue variables on the previous slide, are the instances of x that are local to increment. So, were you able to figure out what this function printed at the end? I'm Doug Lloyd. And this is CS50.
चलो बढ़िया भाई, ये तो कहना है टीचर डगलॉयड के पास।
Welcome everyone, my name is Carter, and today I'm going to show you my guessing game and how I can use debug 50 to help figure out what's wrong with it. So here, I'm trying to write a guessing game that is sort of in the spirit of the elementary school game, where you would guess a number and someone would tell you it's right or wrong, and I called my program guess, so I can run it in the terminal with /guess. Here I go /guess, hit enter, and I have to guess a number. So here I might guess maybe 2 and hit enter, but then I get this flood of messages in the terminal, and I'm wondering, well, what's wrong with this? Why am I getting so many messages here? And to try to figure that out, I can go into my code with code guess.c, and then I can see, well, I'm not entirely sure what might be wrong here. So I need to pause my code at some point. And for that, I can use a breakpoint. So let me go ahead and go to this left side of my guess.c file where I see these red sort of circles pop up. And I can click on one of them to turn it bright red. And at that point, I've set a pause point in my code. And I can use debug 50 to go in and actually step through my code and see what's going on in there. So let me go ahead and type debug 50 of guess, hit enter. So now that I have my code opened up in debug 50, I can see a few different things. I can see that my number variable is currently set to 0, and my guess is currently set to this odd 32,764. But as I go through my code, I'll actually see those numbers sort of fall into place. So if I use this step over button to sort of walk to the next line of my code, I can see that number becomes 5, as I expect it to on line 6. And then as I go to line 8 and step over that, I get prompted for what's my guess. And at that point, I might type, well, 3 again, and I'll hit enter. And then I see guess becomes 3. So now I'm wondering, well, if my guess is wrong, and my number is 5, my guess is 3, shouldn't I only get wrong guess just once? So I'll actually just keep walking through my code with step over, and I'll see I'm printing wrong guess, which seems right. And now I should just exit the program. That should be it. But I really see that my line in that yellow highlight is going back up to 10, line 10 there. And it's actually continuing to go through and print wrong guess. And so at this point, I can actually see that maybe the bug in my code is I shouldn't have used a while loop. I should have maybe used an if statement where I'm only checking for this condition once. So now that my while loop has changed to an if statement, I should be able to recompile my code and see what's changed. So I can use make guess, and then I'll run my code, guess, and when I guess 3, I guess I should get wrong guess. So I'll do 3, and then I'll get wrong guess, but also you're correct. And at this point, there's probably another bug in my code, and so I'll actually leave this one up to you to use debug 50 and see, well, why am I getting both wrong guess and you're correct?
I know रुक जा क्या बोला
And so I'll actually leave this one up to you to use debug 50 and see, well, why am I getting both wrong guess and you're correct? And so guess, but also you're correct. And
क्योंकि वो आगे एकदम क्या बोलते हैं उसको लीनियर टॉप डाउन कोड हमारा टॉप डाउन चलता है ना, इसके लिए वो फिर उस इफ वाला चेक करने के बाद वो फिर उसमें भी चाह रहा है प्रिंट एफ में भी चेक करेगा, वो ख़त्म हो गया इफ वाला ब्लॉक, आगे बढ़ गया वो फिर तो यू आर करेक्ट भी वो प्रिंट करने लग गया। यही है भाई बात, और तो कुछ नहीं है। if yes is not if के साथ यहाँ पे else का भी यूज़ कर सकते हैं, या तो if guess equal to number
And
else
at this point, there's probably another bug in my code, and so I'll actually leave this one up to you to use debug 50 and see, well, why am I getting both wrong guess and you're correct? Welcome, everyone. My name is Carter, and today I'll show you my secret program. You can run the program by typing /secret into your terminal, and if you type in the right password, you should be able to see come on in. So let's try it out. I'll do /secret, and maybe I don't know the secret phrase, so I'll just say let me in, and at which point I don't get any response. So let me try it again and do /secret. Maybe password is the password here, but it's not. And I'll just reveal to you that the password is please. So if I type /secret and I type in please, I should see come on in. But I don't. And so what's the problem here? Well, maybe I should look into my code and maybe step through it bit by bit. So I'll do code secret.c, and I can see the very top of my code starting with this int main void function. To step through my code, remember we can use debug 50 to set a breakpoint or a place to pause in our code. So I can go to this left side here, find a pale red circle, and turn it into a bright red circle as I click it, and set that pause point or that breakpoint. Now I can do debug 50 of secret, and then my code should boot up, and I should be able to pause right at that moment I'm asking the user for their secret phrase. Of course, I have to actually step over that line for it to actually run my program, so I'll then step over, and I can type in my secret phrase of please. Okay, so that seems pretty good. I see that phrase becomes please, and correct is currently false, but it should change to true after I do this check phrase function. So I'll step over, check phrase, and I see it's actually still false, and so of course if I run past line 13, nothing will happen. I actually won't print come on in. So at this point, debug 50 seems to be not really helping me here, right? I've walked through my entire program, but I haven't seen what went wrong in my code. Well, debug 50 has this option to step into a function, actually dive in and see what's happening underneath that hood of that function. So what I can do is go to debug 50 again and run debug 50 with secret, wait for my code to go to that breakpoint again, and I'll walk through that first piece where I type in my phrase please, but now instead of stepping over this check phrase function, I actually want to dive into it and see what's going on underneath there. So I'll do step into in debug 50, and then see I'm setting my password to be please. So if I step over line 22, I should see that password becomes please, as it does on this left-hand side. And now when I check for if phrase is password, I should actually be able to return true, because it seems that phrase is the same as password. So I'll step over that and see, well, actually I get to line 29, and this is kind of subtle, but in C you can't compare two strings using two equal signs. You actually have to use a different function called string compare, or strcmp for short. So to use str compare, I can use strcmp and give it two arguments, phrase and password. And with these two inputs, str compare will tell me, are they exactly equivalent or not? If they are equivalent, strcmp, or store compare, will give me 0 as a value back. So now my code is saying, if these strings are equivalent, and I know they are because store compare is giving me 0, I can go ahead and return true and say that this is the correct password. So with this new code here, I should be able to exit debug 50 and go back to the terminal. And now I can make secret again, run secret, type in my password of please, and now there it is. It says, come on in. And with that, we've seen how debug 50 can help us not only step over our code, but dive into functions and see the bugs inside of them.
Okay. तो debug 50 यूज करना बता रहा है बेसिकली, देखते हैं.
All right, working with single variables is pretty fun, but what if we want to work with a lot of variables, but we don't want to have a bunch of different names flying around our code? In this case, arrays are going to come in really handy. Arrays are a really fundamental data structure for any programming language that you will use, and they're really, really useful, particularly as we'll see in CS50. We use arrays to hold values of the same data type at contiguous memory locations. That is to say, it's a way that we can group a bunch of integers together in memory, or a bunch of characters or floats in memory really close together, and work with them without having to give each one its own unique name, which can get cumbersome after a little while. Now, one way to analogize arrays is to think about your local post office for a second. So step away from programming and just close your eyes and visualize in your mind your local post office. Usually, in most post offices, there's a large bank of post office boxes on the wall. An array is a giant block of contiguous memory, the same way that a mail bank in your post office is a large space on the wall of the post office. Arrays have been partitioned into small, identically sized blocks of space, each of which is called an element, in the same way that the wall at the post office has been partitioned into small, identically sized blocks of space, which we call a P.O. box. Each element of the array can store a certain amount of data, just as each post office box is able to hold a certain amount of mail. What can be stored in each element of the array? It's variables of the same data type, such as int or char. Just like in your post office box, you can only fit things of a similar type, such as letters or small packages. Lastly, we can access each element of the array directly by index number, just as we can access our post office box by knowing its mailbox number. Hopefully that analogy helps you get your head around the idea of arrays by analogizing to something else that you are probably already familiar with. In C, the elements of an array are indexed starting from 0, not from 1, and this is really important. And in fact, this is why we in CS50 and why computer scientists frequently will count from 0. It's because of C's array indexing, which always starts at 0. So if an array consists of n elements, the first element of that array is located at index 0, and the last element of the array is located at index n minus 1. Again, if there's n elements in our array, the last index is n minus 1. So if our array has 50 elements, the first element is located at index 0, and the last element is located at index 49. Unfortunately, or fortunately, depending on your perspective, C is very lenient here. It will not prevent you from going out of bounds of your array. You could access the -3 element of your array or the 59th element of your array if your array only has 50 elements. It won't stop you from your program from compiling, but at runtime you might encounter a dreaded segmentation fault if you start to access memory that is outside the bounds of what you asked your program to give you. So do be careful. What does an array declaration look like? How do we code an array into existence like we code any other variable? There are 3 parts to an array declaration: a type, a name, and a size. This is very similar to a variable declaration, which is just a type and a name, the size element being the special case for an array because we are getting a bunch of them at the same time. So the type is what kind of variable you want each element of the array to be. Do you want it to be an array of integers? Then your data type should be int. Do you want it to be an array of doubles or floats? Data type should be double or float. The name is what you want to call your array. What do you want to name this giant bank of integers or floats or chars or doubles or whatever have you? What do you want to call it? Pretty self-explanatory. Lastly, size, which goes inside of square brackets, is how many elements you would like your array to contain. How many integers do you want? How many floats do you want? So for example, int student grades 40. This declares an array called student grades, which consists of 40 integers. Pretty self-explanatory, I hope. Here's another example. Double menu prices 8. This creates an array called menu prices, which consists of room in memory for 8 doubles. If you think of every element of an array of type data type, so for example, if a single element of an array of type int, the same way you would think of any other variable of type int, all the familiar operations that we discussed previously in the operations video will make sense. So here we could declare an array of booleans called truth table, which consists of room for 10 booleans. And then just like we could just assign a value to any other variable of type boolean, we could say something like truth table square bracket 2, which is how we indicate which element of the truth table? The third element of the truth table, because remember we're counting from 0. So that's how we indicate the third element of the truth table. Truth table 2 equals false, just like we could declare, or we could assign rather, any Boolean type variable to be false. We can also use it in conditions. If truth table 7 equals true, which is to say, if the 8th element of truth table is true, maybe we want to print a message to the user, printf true. And I could also just say truth table 10 equals true, right? Well, I can, but it's pretty dangerous, because remember, we have an array of 10 booleans. So the highest index that the compiler has given us is 9. This program will compile, but if something else in memory exists where we would expect truth table 10 to go, we could suffer a segmentation fault. We might get away with it, but in general, pretty dangerous. So what I'm doing here is legal C, but not necessarily the best move. Now, when you declare and initialize an array simultaneously, there's actually a pretty special syntax that you can use to fill up the array with its starting values. It can get kind of cumbersome to declare an array of size 100 and then have to say element 0 equals this, element 1 equals this, element 2 equals that. What's the point, right? If it's a small array, you could do something like this. Bool truth table 3 equals open curly brace and then comma separate the list of elements that you want to put in the array. Then close curly brace, semicolon. This creates an array of size 3 called truth table with elements false, true, and true. And in fact, the instantiation syntax I have here is exactly the same as doing the individual element syntax below. These two ways of coding would produce the exact same array. Similarly, we could iterate over all of the elements of an array using a loop, which in fact is a very strongly recommended at-home exercise. How do you create an array of 100 integers where every element of the array is its index? So for example, we have an array of 100 integers, and in the first element we want to put 0. In the second element we want to put 1. In the third element we want to put 2, and so on and so on. That's a really good at-home exercise to do that. Here, doesn't look like too much has changed, but notice that in between the square brackets this time, I've actually omitted the number. If you're using this very special instantiation syntax to create an array, you actually don't need to indicate the size of the array beforehand. The compiler is smart enough to know that you actually want an array of size 3 because you put 3 elements to the right of the equal sign. If you had put 4, it would have given you a truth table of size 4, and so on and so on. Arrays are not restricted to a single dimension, which is pretty cool. You can actually have as many size specifiers as you wish. So for example, if you want to create a board for the game Battleship, which if you've ever played is a game that is played with pegs on a 10 by 10 grid, you could create an array like this. You could say bool Battleship square bracket 10 close square bracket 10 close square bracket. And then you can choose to interpret this in your mind as a 10 by 10 grid of cells. Now, in fact, in memory, it really does just remain a 100-element, single-dimensional array. And this, in fact, goes for if you have 3 dimensions or 4 or 5, it really just does become multiply all of the indices or all of the size specifiers together, and you just get a one-dimensional array of that size. But in terms of organization and visualization and human perception, it can be a lot easier to work with a grid if you're working on a game like Tic-Tac-Toe or Battleship or something like that. It's a great abstraction instead of having to think about a tic-tac-toe board as a line of 9 squares or a battleship board as a line of 100 squares. A 10 by 10 grid or a 3 by 3 grid is probably a lot more easy to perceive. Now, something really important about arrays. We can treat each individual element of the array as a variable. We saw that earlier when we were assigning the value true to certain booleans or testing them in conditionals. But we can't treat entire arrays themselves as variables. We cannot, for example, assign one array to another array using the assignment operator. It's not legal C. If we want to, for example, what we would be doing in that example would be to copy one array into another. If we want to do that, we actually need to use a loop to copy over each individual element one at a time. I know it's a little time consuming. So for example, if we had this line of code, or these couple lines of code, would this work?
No.
Well, no, it wouldn't, right? Because we're trying to assign foo to bar. That's not going to work, because it's an array, and we just described that that's not legal C. Instead, if we want to copy the contents of foo into bar, which is what we're trying to do here, we would need a syntax like this. We have a for loop that goes from j is equal to 0 up to 5, and we increment j on every iteration of the loop and assign elements like that. This would result in bar also being 1, 2, 3, 4, 5, but we have to do it this very slow element by element way instead of by just copying the entire array. In other programming languages, more modern ones, you can in fact do just that simple equals syntax, but C, unfortunately, we're not allowed to do that. Now, there's one other thing I want to mention about arrays that can be a little bit tricky the first time that you work with them. We discussed in a video about variable scope that most variables in C, when you call them in functions, are passed by value. Do you remember what it means to pass something by value? It means we're making a copy of the variable that's being passed in. The callee function, the function that's receiving the variable, doesn't get the variable itself. It gets its own local copy of it to work with. Arrays, of course, do not follow this rule. Rather, what we call this is passing by reference. The callee actually does receive the array. It does not receive its own local copy of it. And if you think about it, this kind of makes sense. If arrays are really large, it takes so much time and effort to make a copy of an array of 100 or 1,000 or 10,000 elements that it's not worth it for a function to receive a copy of it, do some work with it, and then just kind of be done with the copy. It doesn't need to have it hanging around anymore. Because arrays are so bulky and cumbersome, we just pass them by reference. We just trust that function to don't break anything. So it does actually get the array. It doesn't get its own local copy of it. So what does this mean then when the callee manipulates elements of the array? What happens? For now, we'll gloss over why exactly this happens, why arrays are passed by reference and everything else is passed by value. But I promise you, we will return and give you the answer to this in a later video. Here's one more exercise for you before we wrap up things on arrays. There's a bunch of code here that's not particularly good style. I'll make that caveat. There's no comments in here, which is pretty bad form, but it's only because I wanted to be able to fit everything on the screen. At the top, you can see that I have two function declarations for set array and set int. Set array apparently takes an array of 4 integers as its input, and set int apparently takes a single integer as its input, but both of them don't have an output. The return type of each one is void. In main, we have a couple of lines of code. We declare an integer variable called a and assign it the value 10. We declare an array of 4 integers called b and assign the elements 0, 1, 2, and 3 respectively. Then we have a call to set int and a call to set array. The definitions of set array and set int are down below at the bottom. And so again, I ask you the question, what gets printed out here at the end of main? There's a printf call. I'm printing out 2 integers. I'm printing out the contents of a and the contents of b square bracket 0. Pause the video here and take a minute. Can you figure out what...
Look, int a equal to 10, int b 4 equals to 0, 1, 2, 3. नहीं, अभी नहीं, 9:30 बजे, 9:30 बजे। हाँ, ले लूँगा। सेट अरे बी, यार कहाँ थे हम? int b 4 equal to 0. हाँ ठीक 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 है। हैं सुबह के लिए बना के रखे हैं। कुछ बोलना ही बेकार है। चुप रहिए, कुछ नहीं बनता। भयंकर, इतना भूख लगा रहता है मेरे को। बासी रोटी खाओ, बहुत बढ़िया। क्या कर सकते हो, नहीं मन है ये सब करने का भाई। अरे ध्यान कहाँ चला, इधर उधर कर देता। सेट इंट, हाँ ठीक है, सेट इंट का वैल्यू तेरा ए मतलब 10, ठीक है। सेट एरे का बी यानी कि तेरा 4 0 1 2 3, हाँ ठीक है। void set array int array 4 array 0 equals 22। अच्छा, और void set int x x equals 22 है 10। set int a का वैल्यू 10 है, तो a वहाँ पे दिया, a इक्वल टू 22 हो जाएगा। प्रिंट ऑफ %d%d/n a 22 आएगा, और b का 0 भी 22 ही आएगा। 22 और स्पेस
This function will
22
print at the
प्रिंट
end.
करेगा और एक न्यू लाइन प्रिंट करेगा।
Hopefully, if you recalled the distinction between passing by value and passing by reference, this problem wasn't too tricky for you. And the answer you would have found is this. If you're not really sure as to why that's the case, take a second, go back, review what I was just discussing about passing arrays by reference versus passing other variables by value, and hopefully it'll make a little bit more sense. It wasn't too tricky for you. Can you figure out
set int a मैं बेवकूफ हूँ। हाँ ठीक है, वो 10 ही होगा क्योंकि वो इसके अंदर जाके जा रहा है ना, ये तो चेंज थोड़ी होगा। बी का 4 गया,
what this
बी का 0 प्रिंट कर रहा है, बी का 0 वो चेंज कर दे रहा है। अरे 0 इक्वल टू 22
function will print at the end? Hopefully, if you recalled the distinction between passing by value and passing by reference, this problem.
क्या हो गया, अटक गया, अटक गया भाई, अटक गया, अटक गया, तो हो गया, हो गया।
If you're not really sure
All
as
right,
to
so let's
why
talk
that's
about
the case,
command line arguments.
take a second, go back,
So far in the
review
course,
what I was just
pretty much
discussing.
all of your programs have probably started like this: int main void. We've been collecting user input if we need it in our program, such as the Mario program, for example, by in-program prompts. We haven't needed to modify the declaration of main because instead, inside of main, we just say, you make a call to get int. How large do you want the pyramid to be? Or you make a call to get float. How much change should I output to the user? There is another way, though, and if we want our users to be able to provide data to our program at runtime instead of while the program is running, a subtle distinction, but sometimes a very useful one, we need a new form of declaring main. We can't use int main void if we want to collect other data at the command line when the user runs their program, hence command line arguments. To collect these command line arguments from the user, change your declaration of main to look like this: int main, open paren, int argc, comma, string argv, square brackets, and then open curly brace. So what does that mean already? Well, we are passing in two parameters or arguments or inputs to main. One, an integer called argc, and the other is what?
A list.
It's an array of strings, right? We see that square bracket notation. It's an array of strings. It's not an individual string. It's an array of strings. And these two arguments, argc and argv, enable you to know what data the user has provided at the command line and how many things they provided at the command line. pretty useful things to work with. argc stands for argument count. And you should know, by the way, that you could call argc whatever you wanted, and you can call argv whatever you wanted. These are just conventional names that we use for them, argument count, and as we'll see in a second, argument vector, argv, but you don't have to call them argc and argv if you don't want to, but conventionally, that's what we do. So anyway, argc, the argument count. It's an integer type variable, and so as you might expect, if we have two things that we're going to be finding out, what the user typed and how much stuff the user typed, argc is going to tell us how much stuff the user typed. So it gives you a number of command line arguments the user typed when the program was executed. So if your program is run /greedy, and inside of your greedy program, your main function has the declaration int main, int argc, string argv square brackets, then argc in that case is 1. Now notice we don't count how many things the user typed after the program name. The program name itself counts as a command line argument. So /greedy, in that case argc is 1. If the user typed /greedy 1024 CS50 at the command line, argc in that case would be 3. And we know this because the way that the division between the strings is detected is whether there is a space or a tab or something like that between them. So any amount of white space, so-called, between the values typed at the command line indicates how many there are. So /greedy space 1024 space CS50, argc in that case is 3.
0, 1, 2, 3.
argv is the argument vector. Vector, by the way, is just another word for an array. And this is an array that stores strings, one string per element, which is the strings that the user actually typed at the command line. When the program was executed. Now, as is the case with any array, if you recall from our discussion of arrays, the first element of argv is always going to be found at argv square bracket 0. That's the first index of the argv array. So that will always, and in fact, that will always be the name of the program. Will always be located at argv square bracket 0. The last element of argv is always found at argv square brackets argc minus 1. Do you see why? Remember how many elements exist in this array? Well, we know that. It's argc number of elements. If the user typed 3 things at the command line, argc is 3. But because in C, when we're working with arrays, each element of the array, or rather the indices of the array, start at 0. If we have 3 elements in our array, we have an element at argv0, an element at argv1, and an element at argv2. There is no element at argv3 in an array of size 3. So that's why the last element of argv can always be found at argv square brackets argc minus 1. So let's assume the user executes the greedy program as follows. If they type at the command line /greedy space 1024 space CS50. And for whatever reason, we've already prepared our greedy program to know and work with these command line arguments. We didn't previously when we worked on it for the greedy problem, but let's say we've now modified it so that we do process the command line arguments in some way. In this case, argv0 is /greedy. What's argv1? Well, it's 1024, right? It is 1024, but here's a really important distinction. Do you remember the data type of argv? It stores strings, right? But it looks like 1024 is an integer value. This is a really important distinction and is actually going to become something that you might encounter in later problems. Everything in argv is stored as a string. So argv1's contents are the string 1024, consisting of those 4 characters. It's as if the user typed 1024 as individual letters or characters. It is not the integer 1024, and so you can't directly work with it by saying, int 1000, or rather int x equals argv1 minus 24. Intuitively, you might think of that as, okay, well, it's 1024 minus 24, so x is equal to 1000. But in fact, that's not the case, because argv1 is a string, the string 1024. Now, there is a function that can be used to convert strings to integers. I won't spoil it for you now, but I'm sure Zamila will be happy to tell you about it in the walkthrough for a future problem. But you can also find functions that would do this in reference 50. If you go to the reference guide, you can find a function that will make this conversion for you. But again, in the walkthrough for a future problem, Zamila will be happy to tell you what function it is that will convert the string 1024 to the integer 1024. All right, so moving on. We've covered argv0, we've covered argv1. What's in argv2? CS50. That one's probably pretty self-explanatory. What's in argv3? Well, again, we don't really know, right? We have an array of size 3. That's how many elements the user typed at the command line. So if we go to argv3, we're now overstepping the bounds of our array. The compiler will let us do this. There's no intuitive problem with it. But in terms of actually what's going to happen, we don't really know. It depends on what is located at the memory where argv3 would be expected to be. And so we could end up getting away scot-free. More likely than not, particularly when we're working with argv as opposed to any other array that's in our program, we're probably going to suffer a segmentation fault. So again, be sure not to overstep the bounds of your arrays, particularly argv, given its high degree of importance in your programs. I'm Doug Lloyd. This is CS50.
चलो आज हमारा फाइनल ये सब खत्म हो गया हमारा, ठीक है. We can finally go to this. ये खत्म क्यों नहीं दिखा? हाँ, दिखा दिया. प्रॉब्लम सेट 2 हम फाइनली करने वाले हैं, ठीक है. प्रॉब्लम सेट 2 देख लेते हैं क्या है. इसको खोल के रख दूं क्या? स्क्रैबल या रीडेबिलिटी, अच्छा दोनों सबमिट करना है. अच्छा, इसमें से एक सबमिट करना है. function if you see any errors when compiling your code with make, fixing the very first error you see, scrolling up as needed, if unsure when it's make zero. Take care. रुक जाओ. पहले हम कंट्रोल सी इसको पीठ पे डाल, भयंकर गर्मी लग रही है. प्रोजेक्ट दबा दिया, कंट्रोल पी. अच्छा, प्रिंट आउट के लिए दबा दिया. प्रोजेक्ट 2 प्रॉब्लम सेट 2 डाल देते हैं. और क्या, और क्विक टू इसको अभी रहने दो. जब ये हो जाएगा ना तब करेंगे, ठीक है. अब चलो. तो बंद करने दो, थोड़ा लॉगिन मारने दो मेरे को. ओह, सेटिंग अप हो गया. वो कुछ नहीं करना पड़ा, ऐसे ही हो गया तो लॉल। चलो बढ़िया है ये तो। सबमिट डन अपडेट 50 मेरे को करना नहीं चाहिए वैसे, ज़रूरत नहीं है मेरे को करने की। स्क्रैबल ये करेंगे हम कल, ठीक है ये करेंगे ये सब। देखते हैं क्या है। तो आज के लिए इतना काफ़ी है, मेरे को खाना खाना है, भूख तो हल्की फुल्की लगी है, लड्डू खा लिया अभी तो भूख थोड़ी कम हो गई। नहीं खाने चाहिए था यार लड्डू, क्या फालतू का। ऐसी गर्मी का मौसम है उसमें मीठा अपने ठूस के गड़बड़ कर रहा हूँ मैं। इसमें कमेंट्स ढंग से और दिए जा सकते थे, पर खैर ये तो पता ही है कि क्या हुआ है इसके साथ। क्या प्रोग्राम था, 70 लाइन का कोड, 70 लाइन का कोड, सॉरी 76 लाइन। छी भाई बहुत गुस्सा आया था भाई इसको बनाने में, मेरे को मेरा दिमाग ख़राब हो गया था। क्रेडिट डॉट सी में, मारियो डॉट सी में तो बहुत इजीली बन गया था, क्रेडिट ने बहुत दिमाग खाया था मेरा। डेमो दे रहा है पता नहीं क्या। चलो कल देखेंगे सब। अब भी क्या करें, थोड़ा गेम खेल ले क्या कि खाना खा ले। मन कर रहा गेम खेलने का। गेम खेल लेते हैं भयंकर, अनस्टॉपेबल भयंकर। क्या क्या आ रहा है, यूजलेस टू बिकम अनस्टॉपेबल। चलो देखते हैं। रियल फेक द गेम ले चैट जीपीटी इज इन द एंड ऑफ आर्टिस्ट। अबे भाई मेरे को अगर मिल जाएगा ना मज़ा आ जाता। अच्छा मेरे को गर्मी लग रही है थोड़ा, चल खेल लेते हैं घर वाले, एक मैच खेल लेते हैं उसके बाद खाने बैठेंगे। तो गर्मी तो लगी रही है। थर्सडे है ना आज, हाँ थर्सडे ही है। कैसे हो गया था, चल रहा है ना स्ट्रीम। ओ भाई गर्म हो जाता है जैसे इसके ऊपर रख दो, तो कैसे थोड़ी देर के लिए अपनी ईयरफोन्स रख के भयंकर गर्म हो गया। ये भी गर्म हो ही रहा है, वैल्यू चलाऊंगा तो भाई पंखा चलना चाहिए। चलना ओपन होने में जो इसका टाइम लगता है ना, दिमाग खराब हो जाता है मेरे को उसको ओपन करते थे। was over देखो भाई, पहला बंदा जिसने को किया भाई, तेरा नाम तो याद रखूंगा प्रवीण भाई। ओपन हुआ था क्या, नहीं ओपन क्यों नहीं हो रहा वैल्यू, कहाँ है। 10 बार दबा दूंगा फिर कैसे ओपन नहीं होगा। अब तो ओपन होके रहेगा, 10 बार दबा दिया। यही करना पड़ता भाई। चलो तैयार हो जाओ थोड़े नूब गेम प्ले के लिए, थोड़ा खेलते हैं फिर खाएंगे, फिर बंद करेंगे फिर जाके खाएंगे अपने। जो वैल्यू के 2020 में ही आया था, कोविड के टाइम में आया था ये वैलोरेंट। 2020 ओ भयंकर बहुत नया है Valorant तो। क्या लेना है क्या? ये सारे शायद अनलॉक ये तो पहले अजीब समझ में आया एबिलिटीज यूज करने में ऑल फायर
Match found.
क्या हुआ ये कौन सा लेना चाहिए पहले तुम बताओ कॉन्फिडेंस बूस्टर करने के लिए जब मेरा कुछ मिलेगा ना पहले हीरो ले लेंगे ब्रो सारे डुएल क्या लेना पर ले लेंगे ब्रेम 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 मगर देने नहीं आंदा मजाक करके कह रहा हूँ
They think I'm an old dog? I'll show them just how many tricks I know.
स्काई स्मोक ऑल्ट फायर अच्छा मतलब ऑल्ट के बाद फायर ऑल्ट दबा के पहले तो जल्दी चले लो मैं लोग क्यों नहीं किया हुआ है मैं सब यूज करने का होता है मतलब फ्लो करने का होता है इसको बोले होता है सारे डुएलिस्ट करने का होता है और मैं सब खेल लिया डुएलिस्ट में गेम में और ये अगर मेरे चैट के लोग हैं पूरे राउंड खत्म के बाद तो मेरे पे कोई चला फिर बंदा का बंदा खेल रहा है
This covert ops thing, I kind of like it. Let's not mess that up.
ये क्या इंसिडेंट ये क्या ऐसे ये मॉड क्यों दबाएंगे तब जाके ये करें पैर पे डाल देंगे
Cutting through.
पीछे पीछे बैक स्टेप
अरे भाई
Finished. Reloading.
प्लान कर जल्दी।
फिनिक्स भाई आपका आवाज
क्या हुआ? इंसान की नहीं लग रही।
नहीं भाई इंसान की सच में नहीं लग रही
एंकर कंटेंट मिल गया लेट्स गो
दानव दैत असुर की भी नहीं लग
बहुत बहुत हो गया बहुत।
अरे मजाक कर रही हूँ मजाक कर रही हूँ
मेरे को तो बच्चे ऐसे सिखवा देंगे मजाक से ठीक है मुझे नहीं आता
सॉरी यार ऑफेंड मत फील करना भाई
One
नहीं
enemy
भाई,
remaining.
भागो
भाई आपका आवाज देख के डर गई यार मैं तो।
करो डिफ्यूज करो डिफ्यूज करो भाई
हैं?
क्या?
डिफ्यूज करो हार गए
अबे निकला। कितने डैमेज
Let's roll,
भाई
Neon.
ड्रीम
Show
क्या
us
था
what
ये
that K-Sec training
अबे
did for
85
you.
का है भाई, मैं क्या बोलूं।
अरे कोई बात नहीं भाई, नाइस, यू कैन डू बेटर।
क्या बोलूं। छोड़ दे स्मोक कर दे।
There.
You know what to do.
Cutting through. Here.
Stim beacon here.
Enemy spotted B. Dead. Someone's A. Shocked one.
हटना फिनिक्स।
उधर क्यों चले गए?
अरे प्लांट करो यार, सच्ची भाई प्लांट कर।
Enemy in
One
defender
enemy
spot.
remaining.
किल ले ले भाई, यही कर ले।
Spike planted.
अरे वहीं से आएगा। हार्दिक भाई। हार्दिक।
Grateful I killed you later.
Damn right we crushed it. Even as I was saying it. When Jet says it, you know what? Forget it.
अबे भाई। क्यों गई? स्मोक करना है ना, तो कहाँ जाओगे बताओ, मैं स्मोक करूँगा। I'll smoke.
KO will not silence us.
Time to jump.
उल्टा ही आ गया भाई तेरा
अबे
बंदा।
क्या था?
Time to jump.
Spike down A. My ult ready.
Someone's A. Spike planted.
आओ तुम। बस आओ। ऊपर से आ जाओ बस। भाई
One enemy remaining.
क्या है ये? मेरे सामने हेड लग रहे हैं। अब देखियो। मेरे सामने हेड लग रहे हैं।
Ultimate's ready.
Easy, mate. There can only be one hero.
हाँ?
Free target practice.
क्या बोल रहा है?
I'll take it.
हेड लग रहा है भाई। वो बंदा क्या मार के गया है मेरे को हेड।
क्या? कितने दिन से खेल रहा है भाई तू ब्रिम?
Gotta go.
एक हफ्ते
Go, go, go.
ब्रिम कितने साल से खेल रहा है?
Gotta go.
भाई तो भाई तुम्हें लगेगी भाई, ग्राइंडिंग टाइम लगती है।
I suggest we keep winning. Go, go, go.
एक महीना खेलो तुम्हारा भी हेड लगेगा।
Cutting through.
I'm out of here.
यू स्लाइड मास्टर आएगी। क्या दूंगा सरप्राइज।
Decoy. Enemy spotted A.
Gotta go.
तूने मेरा किल ले ली।
Enemy A.
तूने मेरा किल ले लिया, मैंने उसे हेड मारा है।
Wiped.
हेड मार के क्या किल लूंगी मैं?
बस बस रन कर।
Enemy spike planted. My ult's ready. Enemy mid.
I'm out of here.
One enemy remaining.
Gotta go.
अबे कोई स्पाइक भी देख लो।
Here we go! Enemy and attacker spawn!
You died last. Good job.
Remember,
जरूरत भी
bullets
है
hurt.
मेरे को तो ये नहीं लग रहा, समझ नहीं आ रहा क्या ही चाहिए।
Go, go, go! Go, go, go! Gotta go! I'm out of here!
Watch and learn.
Gotta go!
Decoy. Enemy spotted. Fully smoked.
One enemy remaining. Flawless.
Please stay alive. I hate making new friends. Go, go, go! Go, go, go! I'm out of here! Go, go, go!
Time to jump. Stim beacon down.
Reloading!
Spike down A.
Down and out.
Reloading.
वो मेरे
मक्की ले भाई उसकी मेरे को दे दिया।
प्लांट का
One enemy remaining.
I got it. Y'all better keep up.
You better keep up. I am a Phoenix lover.
No.
Neon भाई पक्की की स्क्रीन दे दे प्लीज।
Reloading.
इसके पास स्किन नहीं होते, ये गरीब है।
भाई क्या हुआ, क्या करा मैंने?
Cutting through.
अरे नहीं, मैं टच मी से बोल रही थी। ये टच मी तो गरीब है ना?
Reloading!
I'll handle this!
ओ बताए क्या करना है?
Planted. Many enemies B.
अरे भाई हो गया।
My territory, my rules.
Enemy B.
मैं चक्कू लेके क्यों भगता रहता हूँ? चक्कू लेके भगता हूँ किसी चक्कर में।
नियॉन को 138 करे।
One enemy remaining.
नाइस। अरे नियॉन के साथ ही था वो दूसरा है।
That's it. Break time.
भाई उसकी बक्की की स्किन ले लो कोई। भाई मेरे को दे दियो हार्दिक। हार्दिक मेरे को दे दे।
मेरी हेल्प नहीं करते, मैं वो नहीं बोल रहा हूँ, मेरे को ऐड कैसे लग गया उसके, मैं ये बोल रहा था। अच्छे से बताओ कोई ब्लेम कैसे यूज करते हैं, वरना कुछ भी कर दूंगा।
Time to jump.
Enemy B.
अबे यार ये
Spike down B. Last player standing.
99 का है।
लेफ्ट। अरे नाइस। लेफ्ट से आ रहे, वो लेफ्ट से आ रहे हार्दिक भाई। लेफ्ट में देख भाई।
लॉल भाई,
यहाँ
लॉल।
पर क्या बंदा है ये?
फर्स्ट टाइम है क्या तेरा?
Batteries. And I need a recharge.
या फिर तू हेडफोन पहन ले, सुनाई दे देगा तेरे को।
इसका फर्स्ट टाइम है, फर्स्ट टाइम।
डोंट बी अ हेटर, डोंट
या फिर ये हेडफोन नहीं पहना होगा।
डोंट बी अ हेटर, डोंट बी अ हेटर।
इसके कान में रुई डाल रही।
मैं गया वहाँ पे।
अरे भाई कितना मत जोक है यार, तो मैं रात तक हंसूंगा।
हंस ले भाई, हमें क्यों बोल रहे हैं?
जाना
Decoy.
वो क्यों नहीं हो रहा?
तेरे को कौन बोल रहा है भाई?
ठीक है, हटाओ।
तू है कौन भाई?
है कौन? मैं हूँ कौन? ज्यादा
Spike down A.
I'm pissed.
उसका एबिलिटी वहाँ क्या है?
Spot of club.
Last player standing. Spike down A.
भाई तेरा भी फर्स्ट टाइम है क्या?
अरे वो पैन
Still work to do.
भाई चल क्या रहा है तेरे साथ?
अरे वो मैंने अल्ट वही करा था ना, वो सामने आ गई।
अरे नहीं भाई, तू तो ऐसे टहला के मारी है ना वो।
Gotta go.
उसका
मजा आ
प्यार
गया
है
यार। प्यार
ये
है।
हेटर भाई, डोंट डू
I'm out of here.
दोबारा मरूंगा उससे दोबारा।
Safety's up.
अरे
यहाँ बैठूंगा।
Time to jump.
Gotta go.
और मैं मारूंगी, मजा आएगा।
Decoy.
अबे यार फिर मर गया इससे। विंडोज का
अबे ब्रिम उधर फिनिक्स है। अबे वो नहीं होता क्या, इसमें वो ब्लाइंड हो जाता है थोड़ी देर के लिए, वो यूज किया था। पर मैं मर गया भाई उसमें। अबे इस नूब का कोई एस मत होने दे, एस की वैल्यू घट जाएगी भाई।
अब तो
कितनी गलत जगह किया है भाई इस ब्रिम ने।
भाई प्रेम, तेरी भी न्यू नई बार है क्या? पहली बार है क्या तू?
One enemy remaining.
मेरा प्लीज एस है।
अबे उसने
एस था यार।
थैंक यू भाई, थैंक यू।
मैं तेरे को रिपोर्ट मार रही हूँ, रुक।
तेरे को खेलना आता है ब्रिम।
भाई
Go, go, go.
मार दिया मैंने। भाई जेंडर मैटर क्यों करता है, तुम ही बताओ। इतना गुस्सा में होना अभी
13 साल का जो
ओपड़ा फोड़ने का मन।
जिसकी आवाज पतली होती है वो ऐसी आवाज
It's over.
नहीं। भाई तू कितने
I'm
साल
out of here.
अरे
Go.
भाई ये वैलोरेंट
अबे भाई
भाई मार ऐसे छुप गया।
भाई इतना गुस्सा आ रहा है ना मुझ पे।
Last player standing.
Go, go, go.
एस चुराता है, एस चुराता है।
तेरा एम पूरे मैच में चला
3 किल है नहीं तेरे, तूने मेरा एस
Last
चुराया।
round in the half.
अबे मैं कोई भी कीज दबा रहा हूँ भाई, पता नहीं पैनिक में।
देख
कोई
लिया
भी
मैंने
कीज
तेरे
दबा रहा है,
देख लिया।
हार तो जा रहा
ओडिन ले
है।
ले तू ओडिन। ये भाई तू
अरे
ओडिन
नहीं
क्यों ले
भाई।
रहा है भाई?
क्या बोल रहा है?
ओडिन ले ले भाई, ओडिन।
वो नूब है
मेरा
भाई, इसको लग रहा है ये हार जाएंगे, इसलिए ओडिन ले रहे हैं।
तू तो 4 किल पे अटका है भाई, शर्म कर ले अपनी किल पे।
अरे वो मैं मारना नहीं चाह रहा, कितने
मारना
अच्छे
नहीं चाह रहा।
एनिमीज
क्या
हैं।
क्या
I'm out of
तू
here.
व्रत है क्या?
Joke's
मैं
over!
गलत गेम में आ गया बताऊं? गलत गेम में आ गया भाई।
ये
अबे एक माइक में बोलना है यार, पार्टी में भी बोल या पार्टी में बोले, इसमें बोल, पार्टी ऑफ कर देना।
हट बैंक है
Portal closed.
अब भी नहीं चल रही एम ही नहीं चल रही
Spike down A. One enemy remaining. I have the spike.
अबे 61 गोली थी भाई, रिलोड क्यों किया?
आदत है मेरी।
कम है कम 61 का।
ओए बीते
अबे एक ही जगह मत रहो,
आवाज
मेरे को
मत
फिर
कर।
फुटस्टेप सुनाई नहीं देते।
चुप रह।
भाई जल्दी जाओ, प्लान
30
करना है।
seconds left.
अरे डोंट ट्रस्ट मी।
कर दे, प्लांट कर दे, प्लांट कर दे।
उसको पता ही नहीं चल जाएगा भाई, क्या पागल है क्या? प्लांट कर,
10 seconds
ऊपर
left.
जा, ऊपर जा, ऊपर जा, ऊपर जा। अबे मान लो भाई मेरी बात।
जोरू किसकी गन चुरा के फिर यहीं बैठ गया तू? तू पूरे गेम में यहीं क्यों बैठता है?
अबे मत, अरे वो मार देगी भाई, मत रह इधर।
तू 93 उस पे तूने रिलोड मारा है
वो
93।
अरे मेरा आदत है।
अबे वो डिफ्यूज कर रहा है भाई, जल्दी जाओ। ओ फेक किया उसने। Nice.
देख मतलब पता भैया।
रिलोड कर, रिलोड 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 कर, रिलोड खत्म हो गई।
Switching sides.
कर रही थी भाई, करने भी नहीं दिया गया।
No more doubts. We're ready.
नफरत है एक लड़की से।
Gotta go.
क्या?
कोई तो कह रहा था भाई
अरे रायट वाले लोग तो जेंडर
I'm out of here.
वो होता है ना, डर गई। रायट वाले लोग ऐसे करते हैं ना।
Gotta go.
मैं तो ऐसे सोचती हूँ, जेंडर मैटर क्यों कर रहा है?
Reloading.
ओ ये भी तोड़ सकते हैं
अबे कोई ए भी चले।
बर्तन मांज, बर्तन मांज। ये मत खेल भाई, तेरे लिए बर्तन मांज दो।
अरे तेरे से आई कि लेना मेरे
Someone's
सोचना, मैं बर्तन भी मान सकती
लेकिन फिर आइटम मजा आ जाता
हूँ, गेम भी खेल सकती हूँ,
ओए ब्रेन
तुझसे भी अच्छा
चुराने आ रखा मेरे
काम कर
साथ।
सकती हूँ।
अरे बर्तन मार, तुम्हें हेड मारने आ गए।
Go, go, go.
हेड में मारती हूँ ना।
Gotta go.
भाई बी आ जाओ।
Enemy B.
Spike planted.
अबे ये क्या
One enemy
Take it
remaining.
देखा हेड शॉट मारा ना 3। नहीं 2 है।
नाइस नाइस। अबे करना।
Reloading.
2 मारा मैंने हेडशॉट। एक फिनिक्स।
You will expect them to work.
नो
Reloading.
I'll pick them apart. You clean up whatever's
तुम
left.
तेरे से तो अच्छा खेल लेती हूँ भाई।
तुम लोग स्ट्रीम कर रहे
सोच तो
मुझसे तो कर हाँ
बर्तन तक मांजना नहीं आता तेरे को।
अबे मैंने वन टैप ही मारा है, मैंने मारा है भाई लिटरली। एक किल किया मैंने। हाँ किया है।
हाँ बिल्कुल बिल्कुल। मैं मुंबई भाई तेरे।
तो पूछ ले भाई। अबे हट जा। Precise gunplay. अबे ए पे है, सारे ए पे है, सारे ए पे है, सारे ए पे है। होली होली होली।
Gotta go.
Bad luck.
One enemy remaining. Flawless.
What the fuck भाई?
They don't have a single life worth saving.
Reloading.
Reloading.
पर सबसे टॉप पे तो फिनिक्स है ना।
अब हो गया
नहीं
ना?
भाई नहीं भाई नहीं हो रहा मुझे टॉप 10 ले लो तुम जो कर।
अरे भाई
अरे पहले का बात कर रही थी मैं।
हाँ भाई हम स्ट्रीम पे भाई। मैं तो सोच ही नहीं सकता था भाई। स्ट्रीम चालू करने में 1 लाख रुपए लगते हैं भाई। तूने कैसे करा इतना?
गेम चालू करने में 1 लाख रुपए।
अबे तेरे को कुछ नहीं आता।
तू चुप रहे। खेलना तक नहीं आता ढंग से।
I'm out of here.
बात कर रहे हैं।
Spike down A.
यार नियॉन तूने मेरा किल लिया है आल्ट।
अरे किल चो रही है।
मैंने उसे डैमेज करा और मार।
One enemy remaining.
Reloading.
End of
ये क्या हुआ भाई? हेड मारा उसने। मैंने उसको।
Reloading.
Match point.
We win this battle. We win this
अरे
war.
लेकिन मैंने उसको हेड मारा। तेरा
अरे
किल हो
बहुत
या ना
जल्दी
हो।
मैच खत्म हो गया यार भाई। ये वाला गेम जीतेंगे नहीं, हार जाओ।
ओके भाई रोना बंद
तो
कर।
बहुत जल्दी जीत गया ना।
मैं था ना भाई, इसलिए जीत गए यार।
हाँ 7 किल के।
तुझसे भागना चाह रहे हैं ना हम, इसलिए जीत गए।
नहीं यार
भाई ऐसे उड़ उड़ के किस बात? ऊपर हैंड टाइप।
एक तो इसमें मूवमेंट क्यों नहीं होती मेरे को समझ नहीं आता।
Spike down. Attacker spawn.
Spikes in attacker
बॉटम
spawn.
फ्लैग नहीं कर रहा, लेट कर रहा हूँ यार। बॉटम फ्लैग नहीं कर रहा हूँ मैं अभी भी बॉटम फ्लैग 5 किलो।
One enemy remaining. My ultimate.
अबे यार
Defenders win.
What did I say? Don't mess with me.
हाँ जैसे तूने बहुत अच्छा खेल लिया।
ठीक 5 किलो मिलोगे मेरे को, बस 5 किलो। भी तो यूज नहीं करता हूँ, वो भी तो एकदम